All right, good afternoon, everybody. This is Mr. Fasoni. Like I mentioned in third period, I had a little bit of a technical issue when I was trying to solve number one as an example for everybody. I must have made a mistake somewhere, and I think I ended up with an extra negative somewhere that I shouldn't have had one, or vice versa, and I got a solution for number one that was not correct. So as promised to period 3, to make up for that mistake, I'm doing a video to go over the solving of question number one and sharing it with all four of my classes. So question number one is a system of equations with 3 variables. It's x plus y minus 2z equals 5, negative x plus 2y plus z equals 2, and 2x plus 3y minus z equals 9. So remember, I can use substitution or elimination, but with 3 variable systems, it tends to be better to use elimination. So I'm going to go ahead and use elimination for this problem. So my strategy is to find variables that have either a plus or minus 1 attached to them, because those are the easiest ones to manipulate to eliminate other variables. And as I can see, I've got a positive 1x, a negative 1x, and a positive 2x. So I could use x very easily. I've got positive 1y, 2y, and 3y. I could also use the y on this first equation to eliminate the other y's. And also my z's. I've got negative 2z, positive 1z, and negative 1z. So I could use any variable I really want with relative ease and delete the other variables of that type. I believe in class when I goofed up, I used the z variable. So I'm going to try to stick with that. So notice I've got a negative 2z and a negative 1z. So I've got 2 negatives and then a single positive 1z. Well, since I've got 2 negatives, I can use the positive z to eliminate those negative z's. So I'm going to use my middle equation as the equation that I modify by multiplying by some value to delete the other equations or the other variables from the other equations. So I'm just going to set up a workspace here. Let me zoom out a little bit. I'm going to take equation number 1, just rewrite it over here, x plus y minus 2z equals 5. And my goal is to take the second equation that I've got underlined in dark blue on the left. I'm going to take that equation, negative x plus 2y plus z equals positive 2. I'm going to multiply that equation by some value. So when I multiply it through, I will have in that equation a, not negative 2z, a positive 2z. Because remember, my goal is to add the 2 equations together to eliminate one of the variables. So my goal is to eliminate z. So what I'm going to do, now I'll use a different color than blue. I'm going to multiply my equation by a negative 2. Or I apologize, not a negative 2, a positive 2. Because I'm trying to eliminate this negative 2z up here. So I'm multiplying the entire equation by positive 2. Remember, I have to multiply both sides of the equation to keep everything valid. And then I got to use my distributive property. So I'm going to end up with negative 2x plus 4y plus 2z equals 4. This is my new equation that I created using the original equation number 2. I'm going to take this new equation and just place it right below equation 1 over here on the right. That's a 4. And then what I'm going to do is I'm just going to add these 2 equations. And if I add these 2 equations, x plus negative 2x is the same as saying x minus 2x. I get negative x. Y plus 4y gives me 5y. And then the negative 2z and the positive 2z end up canceling each other out. They become 0z or 0. So I don't have to write the z's. And then finally, 5 plus 4 gives me 9. So what I'm going to do is I'm going to hold on to this equation. I'm going to be using it in a minute in a smaller system. This is going to be my two variable equation system, two variable system of equations, equation number 1. But first I have to make another equation before I can do anything else with that. So I'm going to go back to my system. I used the first equation and I subtracted a multiple of the second equation to get that green equation that I created. Well, now this time, since I've used the first and second equations, I'm using the second equation every time to manipulate the other equations. I'm going to choose the third equation and do the exact same thing I did before. 2x plus 3y minus z equals 9. So I just set up another addition problem. 2x plus 3y minus z equals 9. And again, my goal is to get rid of that z value. Well, I can get rid of the z value by just adding a z below it if I'm doing addition. So I have to take my second equation and use it in a way where I'm going to have that positive z. Well, if I look at the second equation again, I already have a positive z in there, which means I don't have to multiply that second equation by anything. I can just place it right underneath equation 3 here. So negative x plus 2y plus z equals positive 2. I didn't have to manipulate it or anything. And again, if I add these two equations together, remember we're treating this like a giant addition problem. 2x plus negative x is going to give me x. 3 plus 2y gives me 5y. And the negative and positive z's again cancel, which is my goal. And then finally 9 plus 2 gives me 11. And at that point, I've now created my second equation with two variables. And now I have enough for a system. So I'm going to build a new system right below, just stack these equations. And at this point, now my goal is to eliminate a second variable. And I can look at this and I can see instantaneously that I already have a positive and a negative x. They are opposites of each other. So at this point, all I have to do is add. I don't have to multiply one equation by some number to change the equation values so I can then add them together and eliminate. I already have the opposites, so if I take the two equations and add them straight away, negative x and positive x eliminate each other. 5 and 5y, 5y and 5y rather, become 10y, and 9 plus 11 becomes 20. I divide by 10 on both. 10s go away. 20 divided by 10, I can eliminate the zeros, and I get y equals 2. I've solved the first of my three variables. I know that y is equal to 2. So if I think about this system, remember my solution is going to, solution is going to be an ordered triplet in parentheses. I've got an x value, a y value, which is going to be 2, and a z value. So I know one of my three values. Well, from here, I can take this value 2 for y, and I can plug it right back into either of these equations. In fact, I'm going to plug it into the second equation here for y. So I'm going to zoom back in. My second equation is x plus 5y equals 11. But I know that that y value, I can replace it with the number 2. Now I just do some multiplication. X plus 10 equals 11. And then finally, all I have to do is solve for x. So I can subtract 10. I'm showing all my work just to make sure everybody's on the same page. Man, my handwriting. Send me to handwriting school, guys. Okay, positive 10, negative 10 cancel. I get x equals 1. So now I've got my second variable in my system. I know that x is equal to 1. All I have to do now is solve for z. Since I've got 2 out of the 3 variables, I can go back to my original system of equations over here. And what I can do is just pick any of the 3 equations, plug my x value in, plug my y value in, and then I can solve for z. So I'll do this on the left. I know my original equation looks like this: x plus y minus 2z equals 5. Well, I'm going to replace my x value with its actual value in the system, which is 1. That's a 1. I'm going to replace my y value with its value in the system. I believe that was a 2, yeah? Yes, it is. And then I'm just going to bring everything else up. So I got 1 plus 2 minus 2z equals 5. We're almost done. The 1 and the 2 can be merged. They're like terms. So 1 plus 2 is going to equal 3. 3 minus 2z equals 5. Now it's just a matter of solving. I know my direction's kind of weird. I should have gone in a downward direction versus up. But if I subtract 3 from both sides, I get negative 2z equals positive 2. And if I divide both sides by negative 2, I get z equals negative 1. So my third variable in this equation, or this system of equations, is negative 1. In class, I got like a positive 2 or a negative 2 for the third variable, which worked on one of the equations, but it didn't work on all 3. So something, I messed up somewhere. And the downside is when you're doing these systems of equations, if you make a mistake somewhere and you can't catch it, that mistake can perpetuate itself throughout the entire system. And by the time you're done solving, you end up getting values that aren't matching with what the answer should be. So you got to be really careful with this stuff. Make sure to, confirm what you're doing as you work through. Otherwise, you're going to run into issues. All right, I'm going to go ahead and stop this. I wanted to make sure that you guys had a chance to see this. I'll throw it up on YouTube, and hopefully it's helpful. I'll see you guys soon.